Hello! So today we are in a natural walk in beautiful New Zealand, and I am planning to use this walk to tell you about the general philosophy of my programming language 42. The idea is that in order to have any hope to do modular reasoning, we need to find ways to tame side effect, input output, non-determinism, and that doesn't mean that we have to go fully functional. If you go fully functional, yes, all the computation is deterministic and you don't have any problem with mutation and aliasing. So if you take in input some data that have a certain structural shape, you can produce a result, and that's it. There is nothing else in your contract. Your test can capture what's happening, and every time a specific scenario is handled by your testing, that scenario has actually been tested. You know that if you repeat the same thing, you will get the same result. And this is not true in normal, imperative or object-oriented languages. And this is a problem, you know? However, functional programming is still perceived as something quite challenging, and I think it's rightfully so. I could make a long discussion on how with functional programming you do get modular reasoning and you do properly intercept and control all of the side effects and all the sources of non-determinism, but I'm not going to discuss this because that's not what I'm trying to do. I'm trying to find ways to get modular reasoning without the need of using the typical tools of functional programming. In particular, the most difficult to tame tools like monads and function composition and passing around functions and avoiding state mutation at all costs absolutely everywhere. I don't think there is the need to go that far in order to get modular reasoning. What you need is just some way to control when sources of non-determinism happen. And so if you go to the basic of object orientation, I think we have an answer. You see, in the very basic idea of object orientation, what you do is calling methods, and you call methods on objects. This means that if you can somehow encode the result, like if you can somehow encode the behavior that could possibly be non-deterministic, that could possibly be important for you, that represent some action that you want to control and understand and reason about, if you can encode this behavior as a method that can only, you know, act over an object of a certain type, now if you don't have the object, you cannot call the method. And this is the main idea. No object, no method call. No method call, no behavior. So in research, this is called object capabilities. And the idea is that there are certain objects that can do the specific task that you care about. And those objects are object capabilities. Oh, I'm in such a good place here, look. So, object capabilities are a natural construct for someone that have a little bit of experience in object orientation. And with object capabilities, you can control what's happening. So the general idea is that, you see, we're entering the dark area where in normal languages you just have those static methods or those publicly accessible constructors, and with those you can just print out by doing system.out.println. Everywhere in the code you can print out, or you can open a file by doing new file.something everywhere in the code. And that doesn't work. What if instead you had a system object, and the system object let you print out, let you write on file, let you do reading on file, you know? Now, every time you do something, you know what you can do and what you cannot do, because you have a bunch of objects that you can reach. So if you control the creation of those more dangerous objects, automatically you control the operation that code can do. So once you have those object capabilities, there are two kinds of things that you can do. The first one is just to give this object capability only to trusted code. But what is trusted code? You know, maybe you're using libraries and they get updated, and now you have no actual concrete idea what the library is doing. You only know about its contract. And again, the contract may not be enough. So a better option is to encapsulate those object capability into other objects that will work like a watchdog. So the capability will be in the underbelly of those other objects, and they will be the guardian of the capability. They will have methods that allows the access of the capability, but they will do some dynamic check. When the method is called, we are not just delegating the behavior to the capability. We should be in the position to do checks to see if this capability call is expected at that point in the program. And so, while you cannot use this technique to guarantee the positive success of your code, you can use this technique to throw an error when something goes wrong. You can use this technique to verify that the programmer assumptions are correct inside of an arbitrary large code that we don't really understand. Now, of course, there is much more than this. There are way more pieces to the puzzle, but I think this is enough for today.